2 trillion galaxies. That's the figure researchers now estimate populate the observable universe. 2 trillion. And here's the detail that should freeze you in place. The majority of them are already gone. Not blown apart. Not shattered. Gone in the most silent, most irreversible way imaginable. No fresh stars forming. No luminosity being generated. Just fading remnants drifting through empty darkness for all of remaining time. If you hold that God created all of this deliberately, you need to account for this. Because 2 trillion is not a statistical blip. It is the vast, dominating bulk of all that exists. And if a cosmos was constructed with intent, assembled according to a blueprint, why does that blueprint yield trillions of lifeless realms for every single one that sparks with something alive? Sit with that thought, because we're about to engage with it honestly, not as a trap, not as an assault on belief, as a genuine physics question that theologians, cosmologists, and philosophers have been quietly grappling with for generations, and most people have never even encountered the data. And before you wave this off as some theoretical exercise, recognize that this isn't a thinker's speculation. This is observed. Astronomers have spent the past 20 years mapping galaxies across the full observable universe, classifying them by whether they're currently producing stars or not. And the trend that emerged was not subtle. It wasn't a coin flip. It wasn't remotely close. The dead dwarf the living by an overwhelming ratio. And that divide keeps growing the deeper out, which also means the deeper back through time. You peer. Let's begin with what dead actually refers to when astronomers use the word, because it's more peculiar than you'd imagine. A galaxy isn't a fixed object. It's an engine. Gas clouds fall inward under gravity, spark into stars. Those stars shine for millions or billions of years, and when they perish, they fling out the materials that get woven into fresh stars, fresh planets, and at least on one occasion we're aware of fresh life. A living galaxy is one where that engine is still operating. Our own Milky Way still produces roughly 1 to 2 new stars annually. Not a lot, but sufficient to consider it alive. A dead galaxy is one where the engine has permanently closed. Astronomers label this quenching. The gas depletes or gets expelled or gets overheated to the point where it can no longer condense into anything. And star creation simply ceases forever. Once a galaxy quenches, it doesn't reignite. There's no comeback. The stars already present keep dimming one after another, transitioning from blazing blue-white behemoths to faint red cinders. And when the final one ultimately flickers out, the galaxy becomes precisely what it will be for the remainder of existence. A cemetery of stellar corpses circling a supermassive black hole, emitting nothing except a gradual dissolution into darkness. And here's a statistic that should truly disturb you. Surveys of galaxies spanning cosmic history reveal that the pace of star creation across the whole universe crested approximately 10 to 11 billion years ago and has been in sharp decline ever afterward. We are inhabiting a universe long past its zenith. Most massive galaxies concluded their primary growth epochs billions of years back. The ones still vigorously birthing stars today are, on a cosmic scale, the outlier, not the norm. Reflect on what that genuinely implies for a moment. If you could condense the complete timeline of the universe into one 24-hour day, the height of star formation, the instant the universe was at its most vibrant, its most productive, landed somewhere around late morning. Everything after that, every galaxy you've ever viewed in a photograph, every star humanity has ever christened, every planet we've ever identified, has occurred during the extended, gradual afternoon, an evening of a universe that has already crossed its peak. We are not inhabiting the opening of a narrative. We are inhabiting well beyond the midpoint of it, in the phase where the lights are already beginning to wink out one after another, quicker than fresh ones are being ignited. There are 3 principal ways a galaxy actually perishes, and each one is its own quiet catastrophe of physics. The first is starvation. The galaxy simply exhausts the fresh gas available to draw in from its environment, and without new fuel, star production decelerates to a halt like a flame with no more timber. The second is stripping, which occurs when a smaller galaxy plunges into a dense cluster of other galaxies, and the superheated gas pervading that cluster physically peels the star-forming matter right out of it as it travels, like gusts ripping laundry off a line. And the third, perhaps the most spectacular, is feedback from the supermassive black hole residing at a galaxy's core. When that black hole feeds aggressively, it can unleash radiation and streams of energy so intense they overheat the surrounding gas, inflating it until it's too scorching and too sparse to ever compress into a star again. Put differently, the very same black hole that may have contributed to shaping a galaxy in its early days can later become the force that silently extinguishes it. There's something nearly lyrical in that if you allow yourself to see it, the entity at the very heart of a galaxy, the thing that secures every star in its trajectory and maintains the entire architecture, is also, in time, the thing that closes the entire architecture down. Astronomers even have a label for this dynamic. They call it coevolution because the expansion of a central black hole and the demise of the galaxy surrounding it seem to progress in tandem, almost as though the two were never independent narratives to start with, just two chapters of the same one. None of these three processes, starvation, stripping, or black hole feedback, unfolds rapidly by human measures. A galaxy doesn't expire in an instant the way a star can conclude in a supernova. It diminishes. It can require hundreds of millions, even billions of years for a galaxy to transition from robustly generating stars to completely quenched. Which means that right now, at this precise instant, scattered throughout the heavens, there are galaxies in every imaginable phase of that progression, some freshly quenched, their final cohort of stars still blazing intensely before they commence the prolonged cooling, others partway along, uneven and faint, and others so far advanced that if you could physically journey there, you discover nothing except a dim reddish glow of waning cinders surrounding a black hole that has long since consumed everything available to it. So, when you hear 2 trillion galaxies, don't envision 2 trillion shimmering spiral marvels like the images from space observatories. Envision a universe where the vast majority of that figure has already moved beyond capacity to generate anything new. Dead light, dead chemistry, dead potential. Now, here's where it becomes personal for anyone who holds this was all crafted intentionally. If you ask most people why they accept the existence of a creator, the response typically circles back to design. The universe appears fine-tuned. The constants of physics are calibrated with such exactness that if adjusted even marginally, would render stars, atoms, or chemistry itself unachievable. Gravity, the strong nuclear force, the cosmological constant, alter any of them even a tiny percentage differently, and you produce a universe devoid of stars, devoid of carbon, devoid of us. That exactness feels like deliberation. It feels like a blueprint. But a blueprint for what, precisely? If the objective is life, if the whole rationale for fine-tuning the cosmos was to ultimately generate beings capable of gazing upward and pondering their maker, then the architecture is staggeringly, almost brutally inefficient. You don't require 2 trillion galaxies to produce one planet harboring life. You don't require galaxies quenching and expiring by the billions across 10 billion years of cosmic history, just to eventually yield a modest blue sphere circling a commonplace yellow star in a commonplace spiral arm of a commonplace galaxy. If the objective was us, the universe performed a colossal volume of superfluous labor and then allowed nearly all of it to go unused. This is not a recent dilemma. It's actually one of the most ancient conflicts in the philosophy of religion, and it bears a name: the problem of cosmic wastefulness. Carl Sagan articulated versions of it decades prior. So did thinkers stretching back centuries before him, well before we even grasped how immense the universe truly was. But it lands differently now that we actually possess the figure. 2 trillion galaxies, the majority of them dead or fading. That's not a theoretical philosophical riddle anymore. That's an observation, and it worsens before it improves, because the 2 trillion isn't even the complete picture. That figure only includes galaxies luminous enough and near enough for our instruments to register. The actual total, once you factor in galaxies too dim, too tiny, or too distant to observe, is almost certainly larger. Every advance in telescope capability over the past century has accomplished the identical thing: raise the tally. When the Hubble Space Telescope initially examined a minuscule, apparently vacant section of sky in 1995, a section tinier than a grain of sand held at arm's reach, it revealed thousands of galaxies packed into that single dark fragment. Extrapolate that concentration across the complete sky, and you arrive at quantities so enormous they cease resembling astronomy and begin resembling a philosophical provocation. Before we proceed, pose yourself a question. Out of 2 trillion galaxies, how many do you suppose are genuinely able to sustain a planet resembling Earth? Not merely any planet. A planet with the appropriate star, the appropriate orbit, the appropriate chemistry, stable enough across billions of years, undisturbed enough for life to actually establish itself and progress all the way to something that can stare at a screen and pose this very question. Hazard a guess. Now, retain that figure in your mind because in a few minutes, we are going to measure it against the actual one, and it is tinier than virtually anyone anticipates. Let's press deeper into the physics because it grows more peculiar the further you venture. Every galaxy, living or dead, is on the identical irreversible journey. The universe isn't merely populated with galaxies that have already expired. It's actively generating more of them every single day. And it will continue doing so until there's nothing remaining to render lifeless. Here's the reason. The universe is expanding, and that expansion is accelerating. As galaxies drift further apart, the gas that any given galaxy could attract to construct new stars becomes increasingly difficult to access. Pair that with the reality that galaxies consume their own gas stockpiles over time, and you arrive at a universe that is fundamentally running dry of fuel. Cosmologists have a phrase for the distant future this produces. The stelliferous era will ultimately conclude. At present, we reside within it. A span stretching roughly from a few 100 million years, following the Big Bang, to approximately 100 trillion years hence, when stars can still emerge. But it is, by its very nature, finite. Long after the final gas cloud compresses into the final star, the universe will transition into what's known as the degenerate era, then the black hole era, and ultimately the dark era, a designation that is not poetic overstatement. It is a precise scientific terminology, where nothing persists except the faint cooling shells of matter and the gradual dissipation of black holes across durations so immense that 100 trillion years begins to resemble a solitary second. So, if you're wondering why God fashioned 2 trillion dead galaxies, the candid response from physics is even more disquieting than the question suggests. Dead galaxies aren't an unfortunate byproduct. They are the endpoint. Every galaxy, without exception, is on an irreversible course toward precisely the same conclusion, ours included. The Milky Way itself is forecast to ultimately merge with the Andromeda Galaxy, combine, exhaust its leftover gas, and quench, identical to the trillions preceding it. Death isn't a flaw in the blueprint. It's the inevitable result embedded in the laws of physics themselves. And this is where the question hones into something nearly unsettling to voice aloud. If dead galaxies are merely where every galaxy ultimately arrives, then asking why did God create so many dead galaxies is somewhat akin to asking why a clock was constructed with so many seconds on it that have already elapsed. The dead ones aren't a distinct class from the living ones. They're the identical galaxies, simply further along the identical countdown, which means the actual question beneath the question isn't about galaxies whatsoever. It's about whether a universe engineered so that everything within it, without exception, ultimately fades to black, can still be deemed a universe constructed with intention, or whether intention and transience were never truly at odds in the first place, and we're the ones who presumed they needed to be. Now, if you're someone who clings to the notion of a purposeful creator, I want to be equitable to that stance, because there are substantive responses here, not merely silence. Remember that estimate you formed earlier about how many of the 2 trillion could realistically harbor a planet resembling Earth? Here's the forthright scientific response. Nobody knows a precise figure, but every calculation that takes fine-tuning earnestly places it at a minuscule, nearly negligible fraction of the whole. Not half, not 1 in 10. Some projections, accounting for stable orbits, the suitable type of star, the correct elemental composition, and sufficient uninterrupted time for a complex life to develop, place the count of genuinely Earth-analogous prospects at fewer than 1 in a million galaxies. And within each of those galaxies, only a modest cluster of stars. And within each of those stellar neighborhoods, at best 1 or 2 planets situated in the habitable zone at all. Apply that arithmetic across 2 trillion galaxies, and you still arrive at a count of candidate worlds substantial enough to sound noteworthy. but express it as a proportion of the total, and the fraction of successful galaxies relative to the 2 trillion aggregate effectively rounds to zero. One reply theologians and philosophers offer is this: perhaps purpose was never intended to be gauged by efficiency. Human beings evaluate the significance of something by questioning whether it was necessary, whether every component serves a result. But that's an industrial mentality imposed on something that might not be a mechanism at all. An artist doesn't need every square inch of canvas to feature the subject of the artwork for the artwork to carry meaning. Empty space, negative space, is integral to the composition. Perhaps a universe containing 2 trillion galaxies, only a sliver of which will ever shelter anything approximating life, isn't extravagant by that same reasoning. Perhaps magnitude itself is the significance. Perhaps the sheer unfathomable enormity is not a defect in the architecture, but the actual declaration that whatever produced this had no need to be economical, had no need to rationalize its decisions in terms of species, on one soggy stone, could straightforwardly scrutinize. Another reply reaches further. Perhaps we are mistaken to presume life is the sole objective being advanced. If the aim was to exhibit the raw magnitude of creative capability, not to yield a maximum efficient output of life, but merely to display what boundless creation manifests as, then 2 trillion galaxies, living or dead, might all be equally the significance, just not in the narrow human, cost-benefit framework we're accustomed to imposing on everything. And then there's a third reply, softer than the preceding two, and perhaps more genuine. Some theologians simply concede they don't know, and that not knowing is itself woven into the design, that a universe constructed to be entirely decipherable by the very creatures inhabiting it would be a diminished, inferior thing compared to one that keeps spawning questions faster than solutions. There's a fourth perspective worth introducing as well, one that derives less from theology and more from cosmology itself. Some researchers observe that you may genuinely require a universe as enormous and as apparently extravagant in order to produce even one planet resembling Earth. The fine-tuning argument operates in both directions. The same precision that enables stars and carbon also demands an immense quantity of iterations for those conditions to actually yield something as particular and delicate as a habitable planet orbiting a steady star at the proper distance with the proper chemistry shielded by the proper combination of a sizable moon and a magnetic field, and a Jupiter-scale neighbor clearing incoming rubble. If you desired favorable odds of that arrangement occurring even once, you might require a universe housing hundreds of billions of galaxies, each containing hundreds of billions of stars, simply to roll the dice frequently enough. Under that interpretation, the 2 trillion galaxies aren't squandered at all. They're closer to the price of entry. Not 2 trillion tries that all needed to work, but 2 trillion tries necessary to render even one triumph statistically probable. But here's a rebuttal to all three of those positions, and it's worth dwelling on because this is where the genuine friction resides. If purpose doesn't demand efficiency, if magnitude itself can be the significance, if exhibition of power outweighs outcome, then the word purpose has been diluted so extensively that it scarcely carries meaning anymore. At that juncture, you could rationalize literally any universe, dead or alive, structured or disordered, by simply recasting what qualifies as purposeful after the fact. And that's the precise same maneuver skeptics accuse religious explanations of performing everywhere else. Whatever the universe happens to resemble, label that the plan. But even that response contains a fracture in it, and it's worth identifying before we continue. If the 2 trillion galaxies were the price of entry for generating one Earth, you'd anticipate life to be scarce in the universe, possibly even exclusive to us. And yet nothing in the physics or the chemistry implies Earth is exceptional in the components it utilized. Carbon, water, energy from a star, none of that is unusual. It's among the most abundant chemistry in the universe, which introduces an awkward possibility for the price of entry reasoning. If the components are abundant, then either life is considerably more prevalent than we've detected thus far, and we simply haven't searched long enough or thoroughly enough yet, or something else. Something we don't comprehend is screening out nearly every opportunity before it gets a chance to become life at all. Either way, the figure 2 trillion ceases appearing like a set cost for a guaranteed result, and begins appearing like a universe still conducting an experiment whose findings aren't yet available. So where does that position us? Perhaps here. Perhaps the truthful stance isn't the 2 trillion dead galaxies demonstrate there's no purpose, and it isn't the 2 trillion dead galaxies demonstrate precisely what the purpose was. Perhaps it's more elementary and more peculiar than either of those. Perhaps the universe is not compelled to conform to the expectations of a species that only developed sufficient cognition to formulate the question within the last several thousand years on a planet that has persisted for slightly more than 4.5 billion of the universe's roughly 14 billion. We are interrogating the cemetery about why it's so vast, while standing on one of the sole plots within it that happens to still have a lamp burning.